Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in CSC in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about numerical integration. In this, what I'm going to explain today is trapezoidal rule and Simpsons. So when it comes to the basics of this numerical integration, so the numerical integration is nothing but a method to approximate the integral of a function. So when an analytical function is going to be difficult and then it should be impossible to obtain. So it involves computing the summation of fraction of values at specific points, so that should be multiplied by x. So numerical integration is nothing but a method which is going to approximate the integral of a function whenever the analytical solution is going to be difficult. And the trapezoidal rule, so the numerical integration method which is going to approximate the integrals by the summation of trapezoids under the curve. And this Simpsons rule is that this is the Simpsons rule. This is the another method where we're going to approximate the integral by fitting the parabolas to the segments of the curve and the summation their areas. So it should be a method which is going to approximate the integral. So by fitting the parabolas and so to the segments of the curve and summing the areas. And quadrature means that so it should be the process of determining the integral of a function using numerical methods. And it is a technique to approximate the integrals using weighted sum of values at specific points, providing high accuracy for polynomials. So Gaussian quadrature, so it is nothing but a technique to approximate the integrals using weighted summation of the functional values at specific points, providing high accuracy for the polynomials. So numerical integration. So here we're going to concentrate on these two topics like trapezoidal rule and Simpsons rule. So the quadrature is nothing but the process of determining the integral of a function using numerical methods. And Gaussian quadrature means it is a technique where we're going to approximate the integrals using weighted summation of fractional values. So when first introduction of this numerical integration. So the numerical integration means that so it should be evaluation of integrals. So if I'm going to have the area under the curve I want to find between a and b, so that one is going to be write it as integral a to b f of x dx. And how can able to simplify this means f of b minus a, so that I can able to get the area in between the two variables I can able to obtain. And so here a and b values are going to be given, and then f of x is the function is going to be determined, and f dash of x must be similar to x only. Suppose I want to find the area in between this graph. So here j is the function integral a to b f of x dx I want to find. Like the example should be so integral 0 to 3. So sin x dx I want to find, integral 0 I want to find. So here the y should be the function. So y should be the f of x dx, y should be the sin x, and a value 0 and b equal to 3. So these are known the integrals representation. So geometrical representation of the definite integral. So if I'm going to draw this, so I'm going to take the x-axis here and then y-axis here. So I want to find the area in between a and b. I want to find it out. So after plotting this graph, so y is the function equal to f of x. So this area is going to be obtained. I want to find. So that one is going to be done through this integral. And next one is rectangular rule. So rectangular rule is the simplest rule. So which is going to be divide the integral and integration interval uniformly in n segments. So let h is the resolution. So here, rectangular rule is the simplest rule. So where you can able to divide the integration interval uniformly into n segment. Let h is the resolution. So where h should be b minus a by n. So the definite integral of f of x between interval is going to be given by integral a to b f of x dx. And here what I'm going to say is that so h of f of x1 plus f of x2 and so on f of xn. This should be the almost all equal to integral a to b f of x dx. So the rectangular rule is the simplest rule. So where we can able to divide the integration interval uniformly into n segments. So the here I'm going to take the h as the resolution as h, and it is going to be defined as b minus a by n. So this definite integral f of x between interval a and b is going to be given by integral a to b f of x dx. So here that one I can able to find it as h of f of x1 plus f of x2 plus 1 f of xn. So here the rectangular rule, here what I'm going to say, so here I plot the graph and then I'm going to be drawn. So between area I want to find in between A and B. So it should be having this area is going to be divided into rectangular areas. So it should be of x1, x2 and so on, xn like this. So this should be the representation of rectangular rule. And next one is so the key points in this trapezoidal rule is that so the trapezoidal rule is more generally more accurate, and the integral is going to be obtained by the same subdivision as before, and then the approximate f by broken line segments with endpoints. So the area under the curve of f between a and b is going to be approximate by n trapezoids of the areas. So that one is going to be presented by so half into f of a plus f of x into h. So this should be one area is what I'm going to be considered. And another one is f of x1 plus f of x2 into h. And like this, I'm going to be finding out all this area under the and trapezoid areas. So the trapezoidal rule is more generally accurate one, and it should be where the integral is going to be divided into subdivisions as before, and then here we're going to have the different line segments. So by taking this sum, we can able to obtain the trapezoidal rule formula. So how can I able to obtain this means? So j is the function I want to find. So that should be integral f of x dx. So that should be written as h into h by 2 into f of a plus 2 into f of x1 plus f of x2 and so on, f of xn plus f of g. So these are all the between the area I'm going to find it out. So here the h is going to be given by b minus a by n. That should be the equation we are able to remember this. So in trapezoidal rule, we are going to be estimate this function resolution function. So that one is going to be b minus a by n. So this will be the final formula where we can able to done this. Based on the equation, I'm going to find this areas between the two definite integrals like trapezoidal rule. So the equation is going to be given by so integral a to b f of x dx. That should be write it as half h by 2 into f of a plus 2 into f of x1 so on and so on. 2 into f of x1 plus 2 so on f of x1 so plus f of. So evaluate this following integral j with n equal to 10. So where uh, the a value should be 0 here, and then b value should be 1. So the f of x value should be e power minus x squared. So this is the f of x function where we're going to find it out. So that one is going to be done through rectangular rule and then as well as through trapezoidal rule also. So I'm going to solve this equation through trapezoidal rule. So by giving this, so a equal to 0, b equal to 1, and then n equal to 10 and h and all this. So what I'm going to say that is, so make a table and then take the j values and xj values and xj square and so on, and then the function e power minus x squared j. So by substituting these values, what I'm going to say, so x is 0 and xj square is also 0. So if I'm going to get 0.1001 and 0.2004, 0.3009. So after starting these values also, I'm going to get these values. Then after that, so once I'm going to get the summation of all this, I'm going to get these values. So substitute these values in this formula what I'm going to be uh, given previously. So according to this trapezoidal. So that should be f of a plus 2 into summation of I equal to n minus 1 f of x I b I and f of bi. So here the h value should be the difference one. So that should be b minus a n by 2, that should be 0.1 by 2 plus, and then we have to multiply with this, so 1 plus 2 into this value I'm going to write, so plus that b value. So finally what I'm going to get, this is the value I'm going to get it according to the trapezoidal, right? So here what I'm going to say is that, so according to the equation I'm going to substitute all the values. So initially make a table like this and then define what should be the j value ranging from, and then xj value and xj square values and all. And obtain all these values and then substitute these values in this equation, finally we're going to get it. So here these are the some of the form equations, some of the examples we are able to derive using this rectangle rule and trapezoidal rule. So this is one of the function f of x where I'm going to get x squared dx and 1 plus 1 1 by 1 plus x dx and cos x plus n square x squared d power 2x and x cubed by 1 plus x power 5 and then x cos x dx. So we learned all the various integration functions where can able to the students can able to solve it. And then when it comes to this Simpsons rule, so the numerical integration means that, so numerical evaluation of integrals, so that should already you know that, so that should be derived by the formulas j is equal to a to b f of x dx, and then that should be f of b minus f of minus b. This thing already you know this, and here b values are going to be given. So this is the function, and this j is a line between the a and b. So previously I have done the rectangular rule and then trapezoidal rule. Now I'm going to show this according to the Simpsons rule. So here what I'm going to say is, in Simpsons rule we are going to be divide the integral of the integration a and b into even number of integrals. So example, n is equal to 2m, or subinterval length h is equal to b minus a by n. So the interval points should be x not equal to 1 and so on, x1 x2 so on, x2 n minus 1 x2 n equal to b. So which is going to be include the n points, and then the total should be to n plus 1 points are going to be taken for the consideration. So here in Simpsons rule, so we're going to be divide the interval of integration into even number of things. And here what I'm going to say that is, so whenever n equal to 2 we are going to be subinterval length, and the interval points are should be x not equal to a, and then x1 x2 and so on, x and 2 and minus 1, so that should be equal to b here. So the which is going to be include the endpoints as well, that should be taken into consideration in the Simpsons rule. So here, if I'm going to take the two subintervals and approximate the function f of x in the interval is in between, so x naught and x2, so that should be write it as x naught plus 2h. So by applying this Lagrange form polynomial, so p2 f x is the functions x naught and f of f naught and x1 f of f1 and x2 and f of f2. So here, so the p2 f of x is going to be defined by the equation x minus x1 into x minus x2 by x naught minus x1 into x naught minus x2 into f of n. And then next one, so similarly I'm going to consider the next x minus x naught into x minus x2 divided by x1 minus x naught into x1 minus x2 into f1. And similarly again I'm going to get, so x minus x naught and x minus x1 and x2 minus x naught into x2 minus x1 and f2. So these are the various polynomial equations where are going to be obtained. So here the denominators what I'm going to consider is 2h square minus h square and 2h square. So these are the denominators what I'm going to consider respectively. So let us consider s equal to x minus x1 by h. Then I am able to get, so p2 of x is equal to 1 by 2 into s minus s1 into f naught minus s plus 1 into s minus s1 into f1 and half into s plus f1 into f. Okay, so like this we are going to be defining this interval here. So the p2 of x is going to be defined by the equation. So p2 of x equal to, so 1 by 2 into s minus f 1 into f naught minus, so s plus 1 into s minus s1 into f1, then half into s plus 1 into sf. So substitute this s into this equation. So this should be this geometrical interpretation of Simpsons rule. So how can I able to do that? So by taking the x and y axis, so I'm going to estimate this area under the A and B. So for this, how can I able to obtain this x1, x2, x3, so on, xn like this. So when I'm going to, after drawing this, the function y is equal to f of x, so I'm going to get this different types of parabola. So I'm going to get, so this should be the first parabola and this should be the second parabola, like this we're going to get last parabola. So this should be the geometrical integration. So next we'll see about the what should be the algorithm for the Simpsons rule. So in order to compute this integral a to b f of x dx, so these are the steps what we are going to follow. So input is nothing but, so a b values and m value and then f naught f so on and to m. And output should be approximate j value. And then here what I have to be compute s naught. So for this s naught I'm going to write f naught plus f2m and s1 should be f1 plus f3 so on f2m minus 1 and s2 is nothing but f2 plus f, so 4 plus on f2m minus 2. So here what I'm going to say, so by substituting this, h is equal to b minus a by 2m. So what I'm going to get, so that should be j is equal to h by 3 into s naught plus 4s1 plus 2s, right? So like this we are going to be compute the values s naught is equal to f naught plus 2 fm. So s1 is equal to f1 plus f3 so on to f of 2m minus 1 and s2 is equal to f2 plus f4 plus so on to m minus 2. And then h is equal to b minus a by 2m, so where j is equal to h by 3, that should be that. And the mathematical expression of numerical integration using Simpsons rules is going to be given by, so integral a to b f of x dx is equal to h by 3 into f naught plus 4 f1 plus 2 f2 and 4 f3 and so on to fn minus 2 and 2 fn minus 1 so on. So this should be the mathematical expression that is going to be derived for Simpsons rule using this numerical integration formula. So let us consider how we are going to be evaluate this using Simpsons rule. So for this, I'm going to given the function like j is equal to integral 0 to 1 ex square minus dx. So by solving this, we're going to get some of the errors as well. So according to the equation, so what I'm going to get, so a equal to 0, b equal to 1, and then 2m should be the 10 value. And h is going to be divided by 1 minus a, that should be b minus a by n by 2. So that should be 0 0.1 is the difference here. So once the difference is obtained, so what I'm going to say that is, so again how we calculated previously in rectangular rule and then trapezoidal rule. The same table what I'm going to be drawn here, and then we're going to consider the j value and then xj and then xj square, and then e power minus xj square is going to be considered. So when I am going to take the values like this, so by taking the value 0 to 10, so here also I'm going to consider this, and xj square is also going to be considered. So here what I'm going to say that is, uh, if I'm going to take this, so e power minus xj square, so here what I'm going to consider, these are the values what I'm going to do, and then after making this, after adding the summation, I'm going to get these values. So after substituting this one in Simpsons rule, so h by 3 into and then 4 into 3.7406, after substituting this, and then again I'm going to get, so what I'm going to get, these are the values I'm going to get. Okay, so like this we are going to do that. So here these are the formulas where the students can able to do these problems. So x square 1 plus x, the same thing previously what I did. The same thing also can able to done through the Simpsons rule as well. Okay, so there should be about this new Simpsons rules and then trapezoidal rule. So here these are the two basic rules what I'm going to follow in order to derive this area of the trapezoids under the curve for the through numerical integration. So first thing is that numerical integration. So that should be given by the normal equation, and then the region in between the trapezoid. How can I able to do that? So that should be done through integral f of x dx. So here also what I'm going to say. So this integral you are going to take. So and then the f of x dx will be the different types of x. So 1 by 1 plus x and 1 by 1 plus e power x square and e power x square, something like this the f of x function should be. So based on that I'm going to do that. So in rectangular rule what I'm going to say, this should be simplest rule, and then where the resolution h is going to be found, that should be an important factor. So the both are going to be found out in trapezoidal rule and as well as in Simpsons rule. Okay, so the definite integral of f of x in between them is going to be given by, so a less than or equal to b less than x less than b, so that should be given. So after substituting this what I'm going to do, so we are going to get into h into f of x1, f of x2 and so on, f of xn. So like this the geometrical representation of rectangular group we can able to show it. And the key points what I derived, so same thing. So if I'm going to consider an example how we're going to solve this, so this should be the basic equation where I have to remember. So integrate f of x dx. So for this what I'm going to get, so this should be the equation where I can able to remember it. So h by 2 into f of a, and then this should be f of b, and between, so 2 into f of x1 plus x2 and f of x1 and minus 1 are going to be given. So here the h is going to be given by b minus a by n. So here integral with integral j. So here what I'm going to say, this is the equation of what I'm going to consider as f of x, and then by substituting by considering a table like this, so we can able to take columns like j, xj values and xj square. So by substituting these values, we are going to get some of the equations. So after substituting this into a given f of x dx, so I'm going to get these and all the values. After making the summation of this, I'm going to get these values and all. Okay. So substitute this. So previously in trapezoidal rule, we can able to write f of a plus 2 into summation of this. So 2 into this, I'm going to write it out, and then b f of b value is I'm going to get this. So same thing if I'm going to solve this through Simpsons rule. So what I'm going to get 0.746. So here also what I'm going to get is according to trapezoidal rule, it should be 0.76 is the value what I'm going to get. And then Simpsons rules. So in Simpsons rules, the same thing we're going to apply, but here we're going to vary this n value should be 2m here, or the subinterval length we're going to be consider it out where that H should be b minus a by n. So the interval point should be x naught, that should be a, and the next to n equal to b. So which is going to be include the points like 2 and plus 1 points are going to be taken into consideration. Suppose if I'm going to find the two subintervals and approximate the function in between them, so then I can able to write x naught plus 2, which is the subinterval ratio between them, and apply this Lagrange polynomial function. So through x naught x1 and x naught f1 f1 and x2 f2. So the denominators are going to be considered here, 2 into x square minus x square into x square respectively, and then less as should be x minus x1 by h, that is going to be defined. So integral 1 by 2 into s into s of s minus 1 into f naught is going to be defined. So the polynomial function of an able to write. So 1 by 2 into s minus s1 into f naught, and s plus 1 into s minus 1 into f1, and then s plus 1 into f2 like this. So here the Simpsons rule. So here is going to be, this should be the graphical geometrical representation of this. And so what should be the algorithm for Simpsons rule is that, so it is going to be compute this integral, and the input should be, these are the values a, b, m, f naught, f1 plus f of 2m, and approximate the value of j. And then here what I'm going to consider is s naught is going to be given by f naught plus 2fm, and s1 should be f of 1 plus f of 3 and so on, f of 3 and minus 1, and f2 should be f2 plus f4 plus 2 and minus 2, and h is going to be given by b minus a by 2, and after substituting this, the h by 3 into s naught for s1 2 into s1. So this should be the final equation where I can able to obtain after substituting all these values. And the mathematical representation for the numerical integration is going to be given by, so s naught. So what is s naught? So that should be f naught plus 2 f2, and then plus f3, and so on like this. So this one I'm going to be evaluate this. Where the integral should be j equal to 2m, so equal to 0, where j is equal to integral 0 to 1. This one. So here in this one, so a equal to 0 and b equal to 1 is going to be considered, and 2m equal to 10. So after getting this, h equal to. So in similar fashion, what I did in the trapezoidal rule and Simpsons rule, so here also I'm going to be drawing the same table, and then here what I'm going to get is that, so if I'm going to substitute all the calculation of all these values, I'm making the summation of this. So substitute all these values. So what I'm going to get, so in the given equation, so that should be h by 3 into, so in this equation I want to substitute it. So h by 3 into f naught, so that should be this value, and 4 into this value, and 2 into this value. So what are the summations I'm going to get? So after substituting all this in this equation, we are going to get the result. So this should be the value what I'm going to get in between them. The same thing will also be same. So according to Simpsons rules, I'm going to get 0.4, and then so according to Simpsons rule, also I'm going to get 0.47. So this and all should be the same. And these are some of the examples what can able to solve with the definite integrals. So it should be done through rectangular as well as through trapezoidal. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.